Hi there. So this is a recap of the lesson that we did on Monday and Tuesday, November 16th and 17th, and it's about sector area. So a sector of a circle is a portion of the circle, sort of like a pizza slice, right? So it's a piece of the circle, um, but it's enclosed by this point here in the center, right? And so we want to figure out what's the area of each of these shaded regions. So what we did in class to begin with was we said, let's assume the area of this entire circle is 120 square units. And then I asked everybody to try to figure out what is the shaded area in each figure. And of course, the main thing that you need to do is figure out, well, what fraction of the circle is actually filled in. We started with this one, which is pretty easy. Maybe you can tell that this is 1/4 of the entire circle. And so the area of this shaded region would be 1/4 of the entire area, or 1/4 of 120, which is 30 square units. Okay, so that was kind of an easy one that we figured out. But now I want to stop and remind you that there's this 1/4, we can kind of tell just by looking at it. There is a way that we could figure that out, because this is a right angle here. So that's a 90-degree angle. And so I know that this 1/4 of the circle, one way that I could represent that is that 90 degrees is out of a total rotation. And so that's 90 degrees out of a total of 360 degrees. But notice that, like, if you reduce 90 over 360, 9 over 36, it reduces to 1/4. So we can represent the fraction that we see here as using this angle as the numerator and then the 360 as the denominator. We did another one in class. We figured out that this was 1/3 of the whole circle that's filled in. And so the area was 1/3 times 120, which was 40 square units. This one was trickier because it kind of looks like it could be 1/6, but it's not. It's actually 1/5 of the circle. And so since that's 1/5 of the circle, the area there was, of course, just 1/5 times 120, which is 24 square units. But in both these cases, then we went back and we circled back and noticed that this angle is 120 degrees. Okay, so that's like 120 out of 360 degrees. That reduces to 1/3. This angle is actually a 72-degree angle, and so that is like 72 out of 360 degrees, which reduces to 1/5. This is the weirdest one, but of course we got this bigger angle here, but you can tell looking that this is 1/4 of the circle that's not filled in, and that means that we've got 3/4 of the circle that is filled in. So this area was 3/4 of 120, which is about which is exactly 90 square units. And that means that this is a 270-degree angle here, because this is 90. And if we take 90 away from 360, we have 270 left over. And of course, 270 over 360 reduces to 3/4. So figuring out this fraction of the circle and then multiplying it by the entire area, that's the key to this lesson. So we kind of then broke it down here into more general terms. So this, first of all, this symbol here that you see, it looks like a sort of a zero with a horizontal line through it, is the Greek letter theta. And theta stands for the, in mathematics, we usually use theta to stand for an unknown angle. We often use the letter x to be an unknown number, but if that number is an angle, we'll use theta. And r is the radius. And so what we just figured out is that the area of a sector is the fraction of the circle that's filled in times the area of the whole thing. Okay, so that's kind of where we start with this. We already know the area of the whole thing we represent that as pi times the radius squared. That's how we represent the area of the whole thing. And so we learned that in our last lesson. But then how do we represent the fraction of the circle that's actually filled in? Well, the fraction of the circle that's actually filled in, as I was just showing you, is this angle in degrees out of 360 total degrees. So we can show that fraction as this theta, whatever theta is, it'd be given to you, out of 360 degrees total, right? times the area of the whole thing. So this is your formula that you can use to find the area of a sector. It's theta, this inner angle theta over 360 total degrees, times pi r squared. So then we spent a few minutes doing these two examples here. So I'll do them for you, and you should follow along at home. Maybe take some notes. I mean, you should definitely take some notes on it. So let's find this shaded area. Note that the two pieces of information that we need are given. The radius is 8 inches, and the inner angle theta is 130 degrees. So if you just use that area formula that I just wrote down and then covered up, which is theta over 360 times pi r squared, we just plug in the numbers that we know. We know that theta is 130 degrees, and that's out of 360 degrees. And then we also know that the radius is 8, so I do pi times 8 squared. And then from here, like, we could reduce this fraction and do some other stuff, but all I'm really interested in is getting to a decimal approximation. When we do this, we're going to use, on our calculator, let's just all agree to use 3.14 in place of pi. So you get your calculator and you would do 130 over 360. And for that, I believe if you do this on your calculator, I'll just do it. I think it's, well, so 130 over 360. Okay, so that's 0.36 and then 1 repeating, right? So 0.36111111. But I just leave that in my calculator, and then I'm going to multiply that by 3.14, and then I'll multiply that by 64, because that's pi and then 8 to the second power. And I'll get, so times 3.14 times 64 is 72.568 repeating. Okay, so this is a close decimal approximation, but I want to round that to the nearest hundredth. So that would be this here, this digit. So that rounds to 72.57 square inches. Let's do this other one quickly, and then you can go check the asynchronous assignment. It's got some examples. But this other one, the theta isn't actually given. The theta is, in this case, this angle out here. But we can figure it out pretty quickly because the given angle is 80 degrees, and I can figure out that that means that what's left over is 280 degrees. And I know that the radius is 11 centimeters. So let's just, let's just plug it in to the formula. So the area is 280 over 360 times pi times 11 squared. Again, I got this 280 because that's this angle that's outside here. And if you plug it into your calculator, I believe you get 0.7 repeating for this part, and then times pi, and times 121, because 11 squared is 121. Great. And then chug it through your calculator, and I believe that you get the final area. Here, let's just make sure that I'm right. So I'll do this. So 28 over 36 is 0.7 repeating times 3.14, and then times 121. And so I got 295.51. And you can check that on your calculator if you like, but that's how we got that area. So you should now go to the asynchronous assignment, and there are 6 problems, but you have to round them correctly, and you always have to use pi equals 3.14. So good luck on that, and I'll see you next time.